Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to be looking at exam question number 2 under reaction rate. So, without wasting any further time, let's just dive into it. It says the reaction of zinc and excess dilute hydrochloric acid. Okay, so if this is in excess, it means zinc. It is a what? It is a limiting reagent or reactant. Okay, is used to investigate factors that affect reaction rate. Okay, so we have zinc, 2 moles of it, blah blah blah, and all of that. The reaction condition used and the results obtained for each experiment are summarized in the table below. The same mass of zinc is used in all experiments. So now they are eliminating surface area as a fact. So we cannot have surface area as a fact. So the factors that we are left with, it is concentration, temperature, as well as a catalyst. Okay, but remember, volume does not have an influence on this one. Okay, so the block of volume, even if we ignore it, it's fine, because remember, volume does not affect the reaction rate. Okay, yes, only on a reaction rate, but on chemical equilibrium, the volume does affect the equilibrium. Why? Because when we decrease the volume or increase the volume, we are affecting the pH. So they tell us the zinc is completely covered in all reaction. The reaction time is taken. The reaction time is the time taken the reaction to be complete, or okay, reaction time. This is not the rate; it is the reaction time. Okay. So experiment 1, they used 2 moles of HCl. Then they used powder. They used 25 moles of HCl. All until yeah, it's fine. We won't interpret now. Another thing that I want you to be aware of, it is fair and unfair comparison. If a comparison, it is unfair, if now, let me do this. We won't need this. Remember, a volume is not a factor, okay? We say a comparison, it is unfair if we compare them. If you compare the experiments that we are comparing have 2 independent variables. Remember, the topic that we are dealing with here, it is reaction rate. So the dependent factor, it is what? It is reaction rate, the rate of reaction. The independent factor, it is what? Concentration, state of division, as well as temperature. Okay, yes. So now, okay. Let me remove this. Remember, surface state of division is the same as surface area. Okay. So no catalyst here was added or whatever. Maybe, we don't know. We'll see. Maybe a catalyst was added or not. So let's look at experiment 1 and 2. Experiment 1 and 2, can I compare these? Okay, let's see. Concentration is not the same, okay? But the state of division is also not the same. So I cannot compare experiment 1 and 2, because why? There are 2 independent factors. Can you see there are 2 things that are changed in that experiment? So I cannot compare experiment 1 and experiment 2. But can I compare experiment 1 and experiment 3? Let's see. The concentration is not the same, but the powder is the same. The temperature is the same. So I can compare this. This is a fair comparison, because why? There is only one independent factor, which is what? Which is concentration. Remember, in independent factor, it is a factor that is changed. Okay. Then let's look at 2 and 4. 2 and 4, concentration is the same. State of division is the same. Temperature is the same. This is the same reaction. So it means the reaction time will be the same for this, because now can you see everything is the same for both of them. So now this is not fair also, because now why? The conditions are the same. There's no independent factor. So it means now there's no dependent factor, there's no independent factor, because they are the same. I repeat, why am I saying X is 14 minutes? Because now can you see all the factors are the same. They're off. Remember, I do not consider volume. Why? Because volume is not a factor that affects reaction rate. Okay? Then, yeah, whatever. Okay, it's fine. They say experiment 1 and experiment 5 are compared. Experiment 1 and experiment 5 are compared. Write down the independent variable. What is the independent variable? It is a variable that is changed. Let's see. Concentration is still the same. Okay. This is powder. Powder is the same. Okay. But can you see now the temperature? It is for experiment 1, it is 25. For experiment 3, it is for experiment 5, sorry, it is 35. So it is changed. So this is what we call the independent factor. So the independent factor, it is temperature. Then define reaction rate. Remember, it is the change in concentration of products or reactants per per unit time. Please know your definitions very well. Per unit time. If you do not have per unit time, it's zero. 10.3, write down the value of X in experiment 4 for 2 marks. Can you see you needed to interpret that it is how much? It is 14. Okay, why? Because they have the same if they said Y, you would have said the reaction conditions for experiment 1, for experiment 2 and experiment 4 are the same. Okay, yes. The Maxwell Boltzmann energy distribution curve for particles in each of experiment 1, 3 and 5 are compared. Okay, now let's look. I don't know which one is the original one, but okay, it's fine. Let's see. If it is 1, experiment 1, experiment 3, experiment 5. Okay, the concentration for this one. Okay, concentration here. Okay, if I check here, B has the highest, experiment 3 has the highest concentration. So I expect B to be 3. Why? Because it has the highest concentration. Remember the concentration, it is like this. If I increase the concentration, it will be like that. Okay, so I want to believe that this one, it is experiment 3. Why? Because it has the highest concentration. Can you see that? Then let's compare another things again. Another things that you can compare. Can you see they are all powders, right? Now another thing we can compare is temperature. Can you see now which one is at the highest temperature? The one at the highest temperature, it is experiment 5. So the one that is like this, if this is the original graph, the one that is more towards this side, okay, the peak should be lower. The one that is more towards that side, that has like this, it should be experiment 5. Why? Because now the temperature, it is the highest temperature. So which one is that? Can you see now the one that is the lowest peak? It is this one. Can you see? Can you see? So I want to believe that experiment 3, it is A. Sorry, C, it is experiment 5. Then it means this one, it is experiment 1. Okay? Okay, yes. So let's do that, experiment 1. Now, remember, what does this represent? Represent a sufficient with, sorry, particles with sufficient kinetic energy. This is the activation energy, okay? Identify the graph A, B, C that represent the following. Experiment 3, we are saying it is B. Why? It has the highest or the most concentration. It has the most concentration. Okay. Experiment 5, we said it is C. Why? It has more temperature. Okay. It has higher temperature. Sorry about the bad English. It has a higher temperature. Okay. Okay, yes. Now they say experiment 6 is now conducted using a catalyst in the same reaction condition as experiment 6. As experiment 1. So I know experiment 6 will have a what? Will have a higher reaction rate than experiment 1. Why? Because why? They added a catalyst. Now they ask you, what is a function of a catalyst? A function of a catalyst, it increases the reaction rate or the rate of reaction. Okay. by lowering their activation energy. Okay. They say, how will the heat of reaction 6 compare to the heat of experiment 1? Remember, they told you that the conduct is conducted using a catalyst and the same reaction conditions as for experiment 1. So everything will be the same, just that what will differ is that this one uses a catalyst. So now the heat will be the same, equal to, okay, will be equal to. Now they say to us, calculate the average rate in mole per minute, okay, in mole per minute with respect to zinc for experiment 2, if 1.5 grams of zinc is used. So remember the rate, okay, the rate is equal to, let me write it here, the rate is equal to, they want what? In terms of mole and minute. So it's going to be moles, or number of moles divided by, okay, change in number of moles divided by change in time, okay? But now they want, with respect to zinc, what is a zinc? Zinc, it is a reactant. So if zinc is it is a reactant, can you see it's going to be negative? The answer that you're going to get it is negative. Why? Because now zinc are being used up. So if zinc are being used up, it will be better if you use a negative there. Why? Because we want the rate of, remember the rate is always positive, okay? It tells you per unit time. So, but since we want the rate of the reactant, we will put a negative. But if they wanted the rate maybe of H2, we will have said just rate is equal to change in number of moles of H2. This is number of moles of zinc. Okay, let's just specify number of moles of zinc. But now, do we have number of moles of zinc? No, we do not have number of moles of zinc initially. Why? Because now what we are given here, it is what? It is the mass. Okay, so we're going to say number of moles is equal to mass divided by molar mass. What is the mass, number of moles? We do not know. What is the mass? The mass, it is 1.5. What is the molar mass of zinc? I think it is 65, if I remember very well. We have the number of moles of zinc. It is how much? Let me use my calculator quickly. 1.5 divided by 65 thereof, I get something like 0.23. 0.23. Sorry. 0.023 moles. Okay. This is 2 decimal. Remember I said after a comma, if there is a 0, you do not count it. You start counting from a number. Okay. Therefore, I come here and say the rate will be negative. Therefore, remember, change it is final minus initial. What is final? The final will be 0. Okay. Minus the initial, it is what? It is 0.0223. Okay. Divide by, what is the time? Time for reaction mark experiment 2. What is the time that, okay, it is 14, okay? So time initial, it is 5. So time final, it is 14 at the completion of the reaction minus 0 thereof, okay? Therefore, let me use my calculator and see how much I get. I'm going to say negative into 0 minus 0.023 divided by 14. Remember the time that I'm giving here, I'm giving this time in minutes. So I do not need to convert these minutes to seconds. Why? Because now they want it in mole per minute. So when I punch that on my calculator, I get something like I get something like 0.00164. Okay, what? Mole per minute. Okay, mole per, let me do this, mole per minute. Or this is still the same. If you write this in scientific, I'm gonna say, okay, I want this in scientific, then the answer that I get, it is something like 1,64 times 10 to the power of negative 3 mole per minute. Okay, let's see. Can you see now the answer here? It is 1,64 0.65. Why? It is maybe because of the rounding off. Here, maybe instead of using 0.023, they used 0 minus, let me see, 0 minus 0.02 divided by 14, if it gives me the same answer. Okay, let me see if they use 0.0232. So yes, it's just a matter of rounding off. Okay, so I want to believe there was a range for this question thereof. Okay, yes, but remember, in the exam you won't get it like this. I took it from a very nice study guide thereof. Okay, that we use. So this is what was required of you. The first mark that you'll get, it is you seeing that you need to convert this number of moles into what? Sorry, the mass into number of moles, then coming here, substituting here, okay, then substituting also here, then getting the final answer. Okay, yes. Now if you do not put the negative here, the answer that you'll get, it is negative. Maybe they might accept that or not. Okay, so yes, thank you very much. That's all I had for you in today's video. Let's meet again on the next video. Thank you.